Okay guys, I'm going to go over some of the problems from 5.3 day 2, and then I would love to answer any questions you have about the rest of it, okay? First thing I'm going to do is I'm going to start with number 1, sine of theta equals 4/5, and theta is somewhere between pi over 2 and pi. So I am in the second quadrant. So here's pi over 2 and here's pi. So I'm some triangle in the second quadrant with theta being the central angle, and sine of the angle is 4/5. So opposite and hypotenuse is what we have. Okay. Sorry, I'm trying to adjust the camera right quick. Okay. Then the question is, what is tangent of half the angle? Yeah? So I have to use my tan formula for a half angle. And we've actually got 3 of them, but I said that I had a preference, and my preference was the 1 minus cosine of theta divided by sine of theta. So if I got to choose, I would choose that one. And let me go a little bit lower. Okay. So if I fill this in, I've got 1 minus the cosine. Well, this is a 5 and that's a 4, so that must be a 3. So the cosine is going to be adjacent over hypotenuse, so that's a negative 3/5, so I'm going to make that plus 3/5, divided by sine, which is 4/5. And then I'm going to do common denominator. So the common denominator in the numerator would be 5. And then 5 plus 3 is 8. So I've got 8/5 divided by 4/5, multiplied by the reciprocal, 5/4. 5 simplify out, 8 divided by 4 is 2, so the final answer is 2. Okay. I'm going to do number, let's see. I'm going to do number 4. No, I don't want to do that. I want to do one with a square root. I guess I'll do this one because this is the only one with a square root. Okay. Theta is between pi and 3 pi over 2, so we are in the third quadrant. Some triangle. And it tells me that tangent of theta equals square root of 6/12. So I know that opposite is square root of 6, and adjacent is 12. But if I'm in this quadrant, I know going down is negative and going left is negative. And then as far as finding the hypotenuse, all I got to do is do the Pythagorean theorem. So negative square root of 6 squared plus negative 12 squared. I feel like this is very similar to a problem that I worked in the extra problems to help with this, but oh well. Equals the hypotenuse squared, so that's 6, because negative times a negative is positive, and the square root of 6 squared is 6, plus 144. So c squared equals 150. Oh, maybe it wasn't. Maybe I just helped somebody. So then c equals the square root of 150. 25 goes into that 6 times, so this is going to be 5√6. Cool? Then the question is, what is cosine of half the angle? Cosine of theta divided by 2 is equivalent to either the plus or the minus of the square root of 1 plus cosine of the angle divided by 2. So the question at first is it plus or is it minus, yeah? And here's the thing. When I deal with an angle in this quadrant, so I'm going to go ahead and do decimals because it makes it a little bit decimals. I'm going to do degrees because that makes it easier to think about. I'm going to remind you this is 180 and this is 270. Well, half of 180 is 90. And 180 would be like the smallest it could be, even though it would have to be like 181 or 182. So it would have to be greater than 90, right? So it'd have to go in this direction. And then half of 270 is 135. So the most it could be, even though it couldn't even be that, is 270, which is cut in half 135. So the angle is somewhere in this space, okay, if I cut it in half, I mean. So theta is somewhere in here, theta cut in half is somewhere in here. You pick any angle in here, say 260, cut that in half, and you get 130, it's in here, right? So when I think about over here, I got a triangle in this quadrant. Left is negative, up is positive, hypotenuse is always positive. So as far as cosine goes, cosine is adjacent over hypotenuse, that would be negative. So we are dealing with a negative on this. Okay, so I just got to fill it in. Negative 1 plus the cosine. So my triangle got kind of messy. This is a negative 12 on this side. So cosine is adjacent over hypotenuse. So negative 12 over 5 root 6. And then over 2. Okay, I'm probably going to use this space over here to simplify that. So, I'm going to go ahead and write that again. The square root of, well, not with that one, negative square root of 1, and I'm going to go ahead and say minus 12 over 5 root 6 all over 2. Okay, if I were to do a common denominator, well, first I think I'm going to rationalize. I'm going to multiply top and bottom by square root of 6 on this. And so this becomes, in and of itself, 12 square roots of 6 over 5 times 6, which is 30. And then I'm going to simplify that. 12 and 30, they both divide by 6. This goes into it twice, and it goes into this 5 times. So here's what I've got. Negative the square root of 1 minus the fraction 2 root 6 over 5 over 2, which is over 1. So I'm going to make my common denominator 5. And I've got negative the square root of 5 minus 2 root 6 over the common denominator 5 over 2 over 1, flip and multiply by 1/2. And then we'll have negative square root of 5 minus 2 square roots of 6 all over 10 when I multiply, and I'm fine with us stopping there and calling it good. Okay. As far as this identity goes, number 5, both sides look kind of sketchy to me. This side has cosecants and cotangents. Otherwise, I would definitely work from this side just because I don't like half angles. Here's what I'm thinking, though. I'm thinking I'm going to take a half angle identity and square it and see if I can make this match that. Okay? And then I can work backwards. So what I know that sine of a half angle is the square root. So if I square that, then it's just this right here. So I know that if I can get this side to 1 minus cosine of theta over 2, if I can get this side to there, then I can just say, hey, it's this, the square root squared. So I'm going to go ahead and work right to left. I'm going to work the right hand side and go left. Okay, so cosecant is 1 over sine. Cotangent is cosine over sine. And cosecant is 1 over sine. Yeah. So I'm going to combine this into one fraction, 1 minus cosine over sine in the numerator, and then I'm going to multiply by the reciprocal, sine over 2. And I see that my sines can simplify out, and I'm left with 1 minus cosine of theta divided by 2, which I can then say, keeping in mind what I want. The way that I got, or the way that I know that I'm ready is because I got to this right here, but only because I realized that sine of the half angle is the square root, and then squared is that, right? So if I just make it a square root squared, then I can go ahead and say that this right here is sine of theta divided by 2 squared, which equals sine squared of theta divided by 2. And we're done. I hope that makes sense. But the only way that I knew, normally I would replace a half angle in a heartbeat, but because this is cosecants and cotangents, I didn't want to have to go from there. Although, well, let me go ahead and explore going from the other side, because why not? Some of you might have tried that. So if I went from left to right, cosecant minus cotangent over 2 cosecant. It's actually probably not that bad. I know that the sine of the half angle is the square root of 1 minus cosine of theta divided by 2, and then the squared, so those go away, and I'm left with this. So the easiest way to go from here to there is to recognize what this one has and what this one has that this one doesn't, right? The denominator over here is a 2 cosecant. This is just a 2, so if I literally just multiply top and bottom by cosecant, then I might be done. So if I distribute my cosecant, that becomes cosecant. If I distribute my cosecant, that becomes minus cosine times 1 over sine, and this becomes 2 cosecant. This right here is cotangent, and so in fact I have worked my way to that one right there. I guess it's however you see it, however you want to approach it. But this kind of use some trickery. They both do, but. Alright, let's look at some more identities. Number, okay, there are 5 identities on this page, and I know that a lot of people have asked me about, especially 6, 7, and 8. I think I'm going to work 6, 7, and 8, and then I'll let you try 9 and 10, and then if you have questions over that, then I would be happy to chat with you or, you know, work on a picture that you send me, whatever. So number 6. I'm going to use a piece of paper so that I can go from both sides. So let's go from left to right first. Okay, so if I do 2 tangent of the half angle, I'm going to use one of these. When I look at this over here, I see that I've got 1 plus cosine times sine in the denominator, and one of them has a sine in the denominator, one of them has a 1 plus cosine. It honestly doesn't matter which one I pick. I like to pick this one, so I'm going to go ahead and just pick it. So 2 times 1 minus cosine of x divided by sine of x. My goal is to get to this, right? So this is one of those situations where I see, well, I have a sine in the denominator. I still need a 1 plus cosine. So I'm going to literally multiply the top and the bottom just by the thing I need, 1 plus cosine. And when I do that, I can see my numerator is going to be 2 times, and when I distribute that out, I get 1 minus cosine squared. And then I get, and I'm not going to multiply that out because my final answer has it separated. And I see that my numerator over here is sine squared plus 1 minus cosine squared. Well, this right here, when you have a 2 times something, if I had 2x, that literally means one of them plus another one, right? So that means I can split it up, and I could say 1 minus cosine squared plus another 1 minus cosine squared over sine times 1 plus cosine. And then 1 minus cosine squared is sine squared. And I've got my answer. But if I wanted to work right to left, then here's what I would do there. Now the only way that I could do this, if I go right to left, is if I also rewrite what this equals, because without it I don't have a goal other than tangent of half angle, but that doesn't just appear. It appears in one of these forms, and then I have to like mess with it, right? So I guess I'm going to go ahead and do the one I like, 1 minus cosine. So I've got 2 times 1 minus cosine x divided by sine. If I can get here, then I know that I've made it to my final answer. So first I'm going to work this. Now this is going to kind of use the stuff that we just figured out, and so it's going to kind of feel like cheating, but it's not. I know that 1 minus cosine squared is sine squared, and so if I can have sine squared plus sine squared, then I can say that that's 2 sine squared. Now, this is going to be really tempting because I went the route I probably shouldn't have. The route I should have gone was making this another 1 minus cosine squared as opposed to making this a sine squared, but no, that's what I did, so that's what I'm going to go with. It's very tempting to cancel out one of these signs. However, I know that I'm trying to get to a sine in my denominator. Or you could be like, well, Miss Hosky, I'm trying to get to sine over 1 plus cosine, in which case, I mean, we're right there. If I had made this my goal, then I would be done, because sine divided by sine squared divided by sine, 2 sine divided by 1 plus cosine, and then said, hey, that's that. Cool, you're done. So I guess I could branch off. 2 sine squared over sine times 1 plus cosine. Simplify out a cosine or a sine, and you get 2 sine over 1 plus cosine, which we recognize is 2 times this, which is that. So 2 times tangent of x divided by 2. Or I could replace sine squared with 1 minus cosine squared, so kind of going backwards, if you will. Sine of x times 1 plus cosine. And I'm trying to get rid of the 1 plus cosine, so I would have to make that, factor that out into 1 plus cosine times 1 minus cosine. So factor this into the difference of perfect squares, and then recognize that the 1 plus cosines go away, and I'm left with 2 times 1 minus cosine divided by sine, which is just 2 times the tangent of x divided by 2. But remember, I was only able to work this problem by keeping that in mind, keeping a goal in mind, and identifying that before I moved forward. Okay. There's number 6. Let's talk about number 7. So for number 7, I've got tangent of the half angle minus cotangent of the half angle minus 2 cotangent. Okay. Half angle of tangent, it doesn't really matter. Either dealing with this or you're dealing with this one and you're flipping it because cotangent is just the reciprocal. So I think I'll do 1 minus cosine over sine. So 1 minus cosine of x divided by 2. Nope, that's not that. I'm sorry if that was loud. And then minus, now cotangent is the reciprocal of that, yeah? So if tangent of x divided by 2 is 1 minus cosine over sine, then cotangent is sine over 1 minus cosine. So one reason to maybe pick the other one is that then you don't have so many minus signs, but whatever. Keeping in mind my goal is negative 2 times cotangent. So I am going to remind myself that this right here is negative 2 times cosine over sine. So if I can get to that, then I'm good. Now, I'm going to be honest. Most people are going to pick the harder way to start this problem or to continue this problem. And so I'm going to work it the harder way first. If you would like to watch that, but then work it the way that I do it in a minute, the easier way, feel free. It's going to be up to you. Most people will pick doing a common denominator. And so they'll say 1 minus cosine, because I've drilled that into your head, which is not a bad thing. 1 minus cosine, right? Yeah. Okay. So this right here becomes 1 minus cosine, let's see. It becomes 1 minus 2 cosine plus cosine squared. So if I distribute that out, 1 minus cosine plus cosine squared. Minus sine squared over sine times 1 minus cosine. So keeping in mind the answer that I want, I need a sign in the denominator. I have a sign in the denominator. So I'm going to make sure that I remember that I need this to stay and I need that to go away. Okay. Now I'm going to think about what else I can do. Okay. I see cosine squared minus sine squared. It's not cosine squared plus sine squared, it's cosine squared minus sine squared. So cosine squared minus sine squared does equal cosine of 2x. Now if you ended up using this one right here, then you probably ended up with like a sine squared minus a cosine squared. Just remember it's the negative of whatever you set it equal to. Okay, so keeping in mind, I have a cosine in the denominator that I need to get rid of. I've got cosines in my numerator that I need to somehow get rid of. Well, actually, I do need that negative cosine. But what I think I'm going to do is I'm going to replace this, not with this, but with one of these. And the easier thing to do, would be to do this one. 2 cosine squared minus 1, because then I have cosines in my numerator and denominator that hopefully something will simplify out. So cosine squared minus sine squared with 2 cosine squared minus 1. So I've got 1 minus 2 cosine plus my 2 cosine squared minus 1, which I'm replacing from that. So 2 cosine squared minus 1 over sine times 1 minus cosine. And then I can see 1 minus 1, those go away, and I'm left with, I'm going to go ahead and put these in order. No, I'm not. Yeah, no, I'm not. Okay. So negative 2 cosine plus 2 cosine squared over sine times 1 minus cosine. Okay, I know I need my 1 minus cosine to go away, and I notice that in my numerator. Remember, my goal is negative 2 cotangent, which is a negative 2 times a cosine. If I were to factor out a negative 2 cosine, so remember, factoring is like dividing. Negative 2 cosine divided by itself is 1. A positive divided by a negative is negative. And then if I factor out the 2, that's gone. And if I factor out one of the cosines, I'm only left with 1. And then there we go. Sine times 1 minus cosine. Those can go away. And I'm left with negative 2 cotangent of x. But this step right here is what made it this level of difficulty. So I'm going to show you a way to do that, and to start in the same spot but not have to do all this crap, okay? So, if I start again with replacing them with 1 minus cosine divided by sine minus sine divided by 1 minus cosine, you can actually use conjugate pairs on just one of these fractions to make your life a whole lot easier. So if I multiply top and bottom by the conjugate of just this one, 1 plus cosine, then let's see what happens, okay? My denominator right here becomes 1 plus cosine minus cosine, those go away, minus cosine squared. So that becomes 1 minus cosine squared. But if you remember, 1 minus cosine squared, remember the Pythagorean identity, sine squared plus cosine squared equals 1. So 1 minus cosine squared equals sine squared. Then this just equals sine squared, right? And then I've got 1 sign in the numerator and 2 signs in the denominator, and I have just a 1 sign over here. So if I were to simplify out 1 sign with 1 sign, then I'm left with 1 minus cosine over sine minus 1 plus cosine over sine. Cool. And then if I combine this into a single fraction, 1 minus cosine minus the whole thing, 1 plus cosine, all divided by sine, and I distribute my minus sign, then this becomes, I'll cover that up so it don't get confusing, 1 minus cosine minus 1 minus cosine, all divided by sine. The 1's will go away. A negative cosine plus a negative cosine is a negative 2 cosine, and that is negative 2 cotangent. So that's 2 different ways to work from the, what did I do? The left to the right. And there's no way that I would try going from the right to the left. I just wouldn't do it. So, there we go. I hope that makes sense. Okay. One more, let me do number 8 with you guys. So number 8, actually on number 8, what I think I'm going to do is I'm going to get you started. Okay, I'm not going to finish it out for you, but after I do the majority of the first few steps, you should be fine. So sine of x divided by 2 is this square root, okay? It is plus or minus, but we're going to square, so it's fine to just write it as a square root. So I'm going to go ahead and replace that. 1 minus cosine of x divided by 2. Plus, and then the cosine of the half angle is the square root of 1 plus cosine of x divided by 2. And to square something means to, I'm working left to right. To square something means to multiply it by itself, so I'm going to go ahead and do that again. So 1 minus cosine over 2. And the reason why I definitely wanted to work this side is because this is all messy and it's got half angles. I don't like them. And there's not much of anything you can do with that other than create some things using magic. I mean algebra, but magic. Okay, so let's multiply it out. Keeping in mind that if I multiply the square root of 5 times the square root of 5, I get 5. And if I multiply the square root of 5 times the square root of 3, I get the square root of 15. True? So the square root of something times itself is just the 1 minus cosine divided by 2, the interiors, right? If I multiply this times this, and then this times this, they're the same thing I'm going to get. So it's going to be plus 2 of whatever this is. So I'm going to explore that over here. If I take the square root of 1 minus cosine of x divided by 2, and I multiply it by the square root of 1 plus cosine of x divided by 2, then that just becomes the square root of 1 minus cosine over 2 times 1 plus cosine over 2. The numerator becomes 1 minus cosine squared, the denominator becomes 4, and 1 minus cosine squared is sine squared. And the square root of sine squared is sine, and the square root of 4 is 2, which means that I've got 2 of these, okay? I might actually go ahead and leave it as a denominator too so that we have common denominators, but just to be clear, so I multiplied this times this and got that. I multiplied this times this, and then this times this, but they are the same thing, so it's just 2 of the same thing. It's 2 of these, right? And so the square root of this times the square root of that is just the square root of those 2 times each other. Numerator is 1 minus cosine squared. 1 minus cosine squared is sine squared, and the square root of sine squared over 4 is sine over 2. So I'm going to leave that 2 sine over 2, common denominator, so I'm going to leave it alone. And then last, I'm going to multiply this times that. And the square root of this times the square root of that is just 1 plus cosine divided by 2. They all have a common denominator, so what I would expect you to do from here is just add and see what happens. Okay, I hope that helps. And if you still have questions, then you can ask me from there. Let's look at these. So it says write each expression as the sine or cosine of the tangent of a double angle, then find the exact value. Okay, cool. I'm going to go ahead and jump to this one. Cosine squared minus sine squared, I recognize that as this, so that's just cosine of 2 times the angle, whatever that angle is, which means cosine of 2 times 22.5, which is just cosine of 45 degrees, which is square root of 2 over 2. And there's my answer. Okay. Just to address number 13, that looks like this, so it's going to be twice that angle. I think you could plug that in and see. On number 14, 2 cosine squared minus 1. 2 cosine squared minus 1 is cosine of 2x, so I think I'll do that. This is cosine of 2 times the angle, and the angle was pi over 12. So I'm really just asking you what is cosine of pi over 6, because the 2/12 simplify. And at 1/6 pi, although I guess I do have it right there. This is 1/0, so that makes that 1/2, which makes that square root of 3 over 2. So that is the square root of 3 over 2. Alright, I think I'm going to do number 15 and number 18. No, because they're both sine. I'll do number 17 and number 18. Number 17, use half-angle identities to find the exact value of each. So, tangent of 337.5 degrees. Is the same thing as tangent of something cut in half. And so what I'm going to do is I'm going to take 337.5 and I'm going to multiply it by 2. That's 660, 14, and 1. So that's 675 degrees. Watch me be wrong. Okay, 675. If I take 675 and I subtract 360, I'm going to get 315 degrees. So 675 degrees is the same thing as 315 degrees. So me doing that, I might as well be just using 315. And so I will. So tangent of the half angle, I'm going to use the middle one. 1 minus cosine, so remember, whatever this angle is, that's the angle that goes in here. So the angle cut in half, but you just use x there. So even though it is 675, remembering that 675 is the same place as 315, that's what I'm going to plug in right here. Okay? So this might as well be 315. Cosine of 315 degrees divided by sine of 315 degrees. And then I just plug them in. So 1 minus cosine of 315 degrees is a positive square root of 2 over 2. And then sine of 315 is negative square root of 2 over 2. Common denominator, 2 over 2. So I've got 2 minus the square root of 2 over 2. And then when multiplied by the reciprocal, negative 2 over the square root of 2. These 2's are going to simplify out. These 2 right here. I'm going to distribute this negative to both this and to that. So it's going to be negative 2 plus the square root of 2 divided by the square root of 2. But I don't like square roots in the denominator, so we're going to rationalize. I mean, I don't mind them, but as far as like expressions go, it's better without them in the denominator. Okay, so if I distribute that, that's negative 2 root 2. That is 2, and that is 2. And I notice that all of these are divisible by 2. So if I divide this by 2, I get 1. Divide this by 2, I get 1. I divide that by 2, I get 1. My final answer is going to be negative root 2 plus 1, or 1 minus the square root of 2. And there we go. Okay, I should have left more space for that. Number 18. So number 18 says find sine of 19 pi over 12. So using half angle identities, remember the goal is to figure out, like, you can rewrite this as sine of some angle cut in half, yeah? Or 1/2 that angle. So what you do is you just take your angle and multiply it by 2. So 19 pi divided by 12 times 2 is 19 pi over 6, and 19 pi over 6 is more than one rotation, so I'm going to subtract 2 pi, but 2 pi is the same thing as 12 pi over 6. So this might as well be 7 pi over 6. 19 pi over 6 is in the same spot as 7 pi over 6. So their sines and their cosines and their tangents and everything will be the exact same thing. So multiply the angle by 2, and so technically it would be 19 pi over 6, but 19 pi over 6 might as well just be 7 pi over 6. So that's the angle I'm going to use. Okay, so sine of a half angle is a plus or a minus, so we're going to have to talk about that. And then go from there. That's interesting. I might have to think about that. 19/12. Okay. 24/12 is right here. 12/12 is right here. And that would be 18/12 is right here. So 19/12 is right here. So if I think 19/12 and I were to cut that in half, right? So let's assume, what, 285? If you cut that in half, that's going to be less than 180, so it's going to be somewhere up in here, or somewhere over here, which means sine is going to be positive because we're going up. Okay. Oh, no, I don't need to use 19 pi over 6. No, 19 pi over 12, yeah. 19 pi over 12. Okay. I'm going to do a little something real quick. 0 out of 12, 6 out of 12, 12 out of 12, 18 out of 12, and 24 out of 12 pi. And then if you think about 19, 19 is in here. And if you cut this angle in half, it's definitely going to be in this quadrant. Somewhere in here. I mean, 285, yeah, 285 is 142.5, so somewhere in here. And so sine is definitely going to be positive going up. Okay, I hope that helps. If I ask you one like this, it's not going to be that weird. Okay. If I were to assess you on something like that. So, okay, sine is going to be positive, the square root of 1 minus cosine of, I'm going to go ahead and write that, cosine of 7 pi over 6, because that's the angle that we're going to use as opposed to 19 pi over 6. And then divided by 2. So, cosine of 7 pi over 6 is negative square root of 3 over 2. So plus the square root of 3 over 2, which is over 1. Common denominator, so I'm left with the square root of 2 plus the square root of 3 all over the common denominator 2. Multiply by the reciprocal, 1/2, and this becomes the square root of 2 plus the square root of 3, all divided by 4. But I can take the square root of the denominator, and so it becomes this as my answer. And there we go. Okay. Okay. Let's talk about 19. Yeah, let's talk about 19. And then I'll give you some hints about number 20 before I stop the video, okay? Alright, so write an expression involving only sine of theta, cosine theta, which means no double, triple, quadruple angles, right? So I'm going to be honest, I don't believe I left you enough space on here, so you might have to write that on another piece of paper. So I'm going to see what happens, okay? So sine of 3 theta is the same thing as, it's not a double angle, so I can go ahead and just split it up as theta plus 2 theta. I don't know why I put a plus sign, equals cosine. Now that, cosine of 4 theta, you could actually consider it to be 2 times 2 theta, as opposed to, like, it's a double angle of a double angle. But I guess I'll just go ahead and do this. I can show you the connection in a second. 2 theta plus 2 theta. So sine, so using sum and difference, sine of theta plus 2 theta is sine theta cosine, sine theta cosine, sine alpha cosine beta plus or minus sine beta cosine alpha. And my theta, my alpha and my beta are theta and 2 theta. Wow, that was a lot. So sine of alpha, theta, times cosine of beta, 2 theta. This is plus, so plus is still sine, I think we had cosine before. Cosine of alpha, sine of beta, plus cosine of 2 theta plus 2 theta is the same thing as cosine cosine and then minus cosine, or sine sine. So cosine 2 theta times cosine 2 theta minus sine 2 theta sine 2 theta. So this is what I was connecting, or this is what I was saying a second ago. Cosine of 4 theta is equivalent to saying cosine of 2 times 2 theta. So if I have a double angle for cosine of 2x equals cosine squared of x and sine squared of x. So if cosine of 2x equals cosine squared of x minus sine squared of x. But my x is 2 theta, as it is right here. Then that means that's 2 theta and that's 2 theta, and you can see cosine squared minus sine squared. So cosine squared of 2 theta minus sine squared 2 theta. And then we've got sine theta cosine 2 theta plus cosine theta sine 2 theta. Okay. I've got a bunch of double and I've still got double angles. I don't have any triple angles anymore. So let's do some more replacing. Cosine 2 theta. So cosine 2 theta, it really doesn't matter what you replace it with, as long as you replace it with something not a double angle. So I'll go ahead and do cosine squared minus sine squared. So sine of theta times cosine squared minus sine squared. Okay, plus cosine times sine of 2 theta. It's just got one option, 2 sine cosine. So times 2 sine theta cosine theta. Plus cosine squared of 2 theta. So if I just take this and I square it, right? So cosine of 2x squared. So it's going to be cosine squared minus sine squared squared minus, and then sine squared of 2 theta. So if I take sine of 2x and I square it, 2 sine theta cosine theta quantity squared. Then I just distribute and combine like terms if I want to. But honestly, the whole point was to get away from double and triple angles, so nothing has a 3 theta, nothing has a 4 theta, nothing has a 2 theta, everything has just a theta. So I'm going to have some crazy powers and some big expressions, but that was the goal, to just no longer have double, triple, quadruple angles. So if I distribute, I get sine times cosine squared minus sine cubed plus, I'm just multiplying all these together, so I'm going to write 2 sine and then cosine squared plus, if I multiply this out, cosine squared minus sine squared times cosine squared minus sine squared. Then I get cosine to the fourth minus cosine squared sine squared minus cosine squared sine squared, which means minus 2 cosine squared sine squared, or sine squared cosine squared, doesn't really matter. And then plus sine to the fourth. And then this one right here, when you square just something like you're multiplying, like 3xy squared, just means 3 squared x squared y squared. So this would be, I don't know why I wrote that in my space, but I did. Minus 2 squared sine squared and then cosine squared. Now, keep in mind that my answer is the answer that I'm going to have because I picked some specific things to substitute in. You are not necessarily going to pick the exact same things. Remember, we had, for cosine 2 theta, we had 3 different options. Yeah? So, honestly, I'm going to work this out, and I want you to pay attention to it, but I don't want you to worry about it, okay? Because it's fine. I think the only thing I can see that I can combine is this and this. Sine to the fourth, cosine to the fourth, sine cosine squared, I could do that and that. So that's going to be 3 sine cosine squared minus sine cubed plus cosine to the fourth plus sine to the fourth minus 6 sine squared cosine squared. And there's my answer. Guys, I'm okay if you don't even finish that problem. It's not necessary. If you just wrote it all out and then I just said that and then you got mad, well, sorry about it. But yeah, don't worry about that problem. I mean, it's kind of cool that you know that you understand the ideas behind it, but I'm not interested in making you do that quite that much, especially now. So let's talk about number 20. What I want to do is I want to get you started on number 20, and if I'm completely honest, the easiest way to do this is to start from this side, the left side. Even though it's very small, I have a lot of things I can do. So the first thing I can do is I can separate the signs out, and I can say sine times sine squared times sine squared. That is the same thing as sine to the fifth. And then I notice that I have a sine over here while I have a sine over there, so that I'm going to leave alone. Everything else, sine squared and sine squared, I'm going to replace. And by I mean you. So sine squared is this. So if I multiply this times itself, then I can see what happens. The only thing I will say is that there is one trick a little bit later on, so I'll just mention something like this, okay? If you end up with something like sine squared of sine squared of 2x, yeah? So if sine squared of x equals 1 minus cosine of 2x divided by 2, yeah? Then my x, in essence, is 2x, right? So whatever's in here, I double it there. That would equal 1 minus cosine of 4x divided by 2. So whatever I take the sine squared of, I double that inside the cosine. And so then this would be, as an intermediate step, 2 times 2x divided by 2. So just as a if that's still kind of iffy to you. Sine squared of star equals 1 minus cosine of 2 times the star divided by 2, and in our case, the star is 2x. And so that becomes a 4x. Okay, I hope that helps, and I will be definitely available to answer the questions that you have otherwise.